Good evening, everyone. Today we are going to have a revision session for week 1 and week 2. Are you able to hear?
Yes,
Yes,
ma'am.
good
Okay.
evening, ma'am.
Good evening. It's a revision session, fine. Okay. So we started the course with the joint PMF, marginal PMF, conditional PMF, on all this, right? But still we started revising, and we also do some problems along with that. And if you have any doubt in any particular questions, you can ask that also, right? Okay.
Okay, ma'am.
So yeah, in stat one, you guys have studied that if x is any random variable which is following some distribution at that time, let's say x is a discrete random variable, fine. If x is a discrete random variable which is following some distribution, okay, then you used to find probability of x is equal to x at that time. What do you say these things? If you find probability for each and every value of x, it was known as PMF, right? Probability mass function.
Yes, ma'am.
Yes,
In
ma'am.
all that kind of problem, there was some scenario, and you used to define one random variable on an event, and then we simply find PM probability of all the possible events, and uh, the collectively it is called as probability mass function. Fine. Now in this course, we introduce two random variable on the same event. So if there are two random variable, let's say x and y are two discrete or continuous, but let's start with discrete, are two discrete random variable. At that time, how to define the whole event and all the possible probabilities of the particular event? For that, we need joint probability distribution. Are two discrete random variables. Fine. We know that if there is any event, then probability of all possible event, that means summation of all the probability, will be equal to 1, right? Why it is
Yes,
so?
ma'am.
Because that's the rule, right? Because that's what exhaust, like, if all the events are happened, that means all the possibilities are over. That's why the sum should be 1. Okay. So start with the joint PMF. Yeah. Anyone want to answer about this? What is joint PMF? Like if it is interactive session, then it would be good because it's a revision session. So if you also participate, that will be a good. Yeah. First
Joint
20
PMF
minutes
is the probability mass function of uh, multiple random variables taken together.
taken together. Fine. But why do we need to take all the random variables together in a same
And
event?
For
because when
defining the
Ma'am, because when we have many random variables, there will be many possible combinations of random variables occurring together. So to find the individual, the probability of individual cases, we use joint PMF.
Yeah.
yes, ma'am.
Fine. Okay. So let's take an example. You may have seen this example also. There are some numbers, let's say two-digit number, where X is denoting your unit place and Y is somewhat, let's say, or a number modulo 7. At that time, if someone is asking you what is the probability that your number is even number, then how will you proceed with it? Like how will you find that your number is even number? Are you getting my question?
yes, ma'am.
Yes, ma'am.
Yeah. So will you try it or I'll start? X is denoting your unit place number and Y is number modulo 7.
Then for a two
X
digit or
will take the 0 to 9
Okay,
value.
you just start it and just come up with the probability.
for a two digit number,
It's a
ma'am.
two-digit number, yeah.
Okay.
And yeah, it's a totally different question than we have in the lecture.
Yeah, ma'am.
Range of X will be 0 to 9.
Yeah, you can take any number, it's a unit place.
So the probability will be 1 by 2 for getting a even number.
Yeah,
Ma'am,
how?
the
Yeah,
joint probability is
just
1 by
wait for
14.
it. Yeah,
Joint probability is 1 by 14
joint probability of what?
of X and Y happening both.
Sorry, joint probability of what? X and Y of both. But what? The question is, what is the probability? Probability that a number is even.
So for this question, we don't have to consider the we only have to consider the unit place, and unit place
Yeah.
occurs
Even
0 to 9,
even is 1 by
and
2,
half of it is like divided by 2, so we'll get 1 by 2.
and number model of 7 would be 1 by 7. Every seventh number would be modulo. So and they are kind of independent. So uh,
But we don't need to consider the y condition.
Yeah,
okay.
exactly. That was a trick question. Like if it is a two-digit number or any digit number, and X is your unit place, which can take any values lying between 0 to 9. That means there are 10 possibilities, and out of this 10, I can have any number. Like I can take any number like 0, 2, 4, 6, or 8, right? At the place of x. And all these have like equal chances, because when we are having two digit numbers, it will have some 100 numbers, and out of that definitely 50 numbers are even number. Why? Because whenever the x unit place is even, the number will be even. So yeah, you may use, you do not have to use this condition, because it was like general logic by which you can come up with the answer. Okay.
So would
The
this be
the
a
Yes, ma'am.
question
marginal
was
probability, ma'am?
Sorry.
What do we call this probability? Is it marginal or?
It like you see, here the question was the number is even. At that time, you do not have to consider what the values of what the values y are taking, right?
I told for x and y both happening.
X and y both happening. Like what?
Like it is even and it is modulo 7
It is even and not
and modulo 7.
and modulo 7. Okay. At that time, modulo 7 means
Every seventh number would be divisible, so it will be 1 by 7 probability of
why every seventh number? Let's say your y is taking value 0, 1, 2, up to 6, right? Right?
yeah.
Whenever your number is taking value 0, that means what kind of numbers will be?
Numbers are divisible by 7.
Yeah, 7, 14, and all this. So there are some numbers are even, and some actually exactly half are even and exactly half are odd, right?
Yep.
And when will it take 1? The numbers
8,
like 7
15.
plus 1, 14 plus 1, right?
Yes.
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 Yeah, 8, 15, and all these things. Another half are even, half are odd, right?
Yes, ma'am.
If number is 2, then again 8 plus 1, that means 9, 16, and all. So from this
Yes.
data also you can have this is kind of even, like number, what is the probability that number is even? It's actually independent of number modulo 7, right? Isn't it? Can
Yes.
I say
Yep.
that?
Yes.
If I change, like I have introduced joint PMF and introduced two topics simultaneously, independence. See, if I change, let my y is number modulo 2. At that time, what will you say? Is
It,
it
it
is x and y dependent, independent?
ma'am, it's
Yeah, now
dependent
X and Y are
and like
dependent.
that correlation is direct. So it's same as like number being even.
Yeah. See, here also, if I change question by, I have just asked in this question, if it is a two-digit number, then what is the probability that number is even? But I have introduced some extra conditions, extra information. Just a minute. Like mute yourself if you are not speaking anything. Yeah. So I have just given some extra condition, extra information that may or may not be useful for you. Because what is the probability that number is even? So in that case, they do not have nothing to do with the modulo 7. But if I ask that what is the probability that number is even and y is equal to, let's say, 3, then what will be your probability? At that
So
time, these are dependent, right? Because why you
Yes, ma'am.
have to have
why
this one. Yeah.
Ma'am, to your initial question, so what kind of probability is that? Is it marginal? Can we call that as a marginal probability?
Actually, in that case, if we ask just just the number is even or odd, at that time we do not need two random variables. So it's just a probability. You can't define their joint and marginal. Joint and marginal will come when you have to consider both of the random variables simultaneously. Like this question: what is the probability that number is even and y is taking value 3? At that time, you have to consider both x and like both random variable x and y simultaneously. At that time, what comes into picture is joint PMF, right?
Yeah, but why
But
don't we call that as a conditional probability and marginal?
yeah, it will be like when you set y is equal to 3 and you are having all the values of x for that, right? When you set this question at that time, it may not be a joint, it might be marginal or what conditional. For this particular you're asking, or just a previous question where I have asked what is the probability that number is even?
No, for number is even and y is equal to 3.
Yeah.
Is it a conditional probability, or in which case should we consider that situation as a marginal probability?
Okay. See, what is our joint PMF? First, let's start with the joint PMF. Joint PMF is what? Your event is taking value as x, like x is taking value x and t1 or t2 or whatever, so x1 and y is taking y1.
So
That means you
multiple
fixed
event,
something, right?
multiple events happening simultaneously.
Yeah,
Okay.
that's what joint PMF. But when it comes to marginal PMF, at that time, you just fix one random variable and check what all other, like whatever the scenario this point is taking. We will come to marginal PMF. First, just tell me, are you able to calculate this probability?
Ma'am, actually, not sure if it is like everyone understood this, but the first problem you told that two-digit number and unit place it is like 0 to 9. That is fine. How we are getting this? Understand that part that it is half of the number will be even.
Yeah. So what's your question? Can you repeat, please?
Now, how to get this answer, right? How we are getting this answer?
Which one? This
First one.
probability that number is even.
Yeah, first one. Number y is equal to number modulo 7, and what is the probability number is even?
Yeah. So see, that was just a trick question where I have given you 100 numbers, two-digit numbers, 0 to 99, right? At that time, if you do not have any information about x and y, okay, just forget about it. If I give you just a two-digit number and ask you, what is the probability that number is even? Can you solve it without having any information about x and y?
Number is even.
See,
So
okay. I just give you a little small example. Let's say you have
number
your,
is even unit place if it is multiple of 2, like 2, 4, 6, 8, 0. These are
yeah.
the
So your x is taking value. Okay, you are going with that only, right? X is, yeah. Repeat, 2, 4, 6,
4,
8,
6,
right?
8, right?
Yeah. Then
Then number is even, right? This is the
yeah,
first.
number is, and what is the probability that your x will take these values 0, 2, 4, 6, and 8? If it is a number between 0 to 99.
So
1 by 2 man.
half.
Exactly.
Yeah,
1 by
half.
20,
Right?
1 upon 20.
Oh,
Why 1 upon 20?
it is
0 to
50%.
99.
5
Yeah, this is
upon
just a 50%. Yeah. If your x has choices, your x can take any value from 0 to 9. And you have to select. And we know that if number is like your set is 0 to 99, then x taking value 0 to 9 is uniformly distributed. That means each number is exactly 10 times there, right? Isn't it?
Yes, ma'am.
So if you want a number to be even, at that time you will choose your unit place 0, 2, 4, 6 or 8. right? At that time, you are just having a half set from the original one. So that's it. There was no rule to check whether y is taking like what the modulos, it was number modulo 7 or number modulo 8 or anything. It doesn't matter, right? At that time, because you just have to check whether your number was even or odd. That's it, even, right? So you can just go with the x and leave it. There may be like some tricky question where some extra information is given, but you do not have to use that, right? Are you getting my point?
Got
Yes.
it. This is basically kind of we should not consider number modulo 7, but we
Hmm.
just think that what is the probability that number would
And
be a.
even did you get why we do not have to consider it? There was something we seen here. Whenever your y is number modulo 7, at that time 0 means exactly even numbers are exactly even. Half of the numbers are even and half are odd, right? If you
Correct.
see the 7, 14, every like even odd, it will go like that, right?
Right.
Similarly, here to here, 7 to 8, 8 to 9, 9 to 10, even odd, even odd, even odd. That means all the 100 numbers are divided like that. So,
Mm.
so your modulo is whatever number modulo 7, whatever the number is, it doesn't matter. It is wholly depend on what your unit place is taking.
So, so what you are saying is first even and odd 50% probability. Then we consider whether the number is modulo 7 or not. That series also 50% probability. Any number in that.
Yeah, that was just an observation, but
Mm.
here when the question was just whether your question is even or not, you just have to look out to x only. That
Okay, okay,
that was the
okay.
observation I given to you, but it do not have anything to do with it. Like
Got it. I mean, we should not consider y for
yeah,
this.
some questions are actually easy, but sometimes we know more concepts and we want to use everything. So that's why I just introduced this question where you just have to use a general logic.
Ma'am, the way they ask questions, so no one will dare to think that it is a simple thing.
Yeah. So that's why
Ma'am,
it was actually easy,
here
right? Yeah.
here it is the marginal distribution. Means when we are saying probability of even number, then
Uh,
it is the marginal. Is that right?
it's sum of, I guess. It's not marginal. See, uh, if
So
the
for that, we have to calculate f of x
yeah,
and y both, right?
hmm,
No, means x when here x is a even number.
okay,
So probability of even number is marginal of x. We can say that.
okay. Just tell me what's marginal PMF at that time. I will ask you. What do
Marginal
you mean
PMF,
by marginal PMF? Yeah,
we are taking x as fixed and changing y
right.
for all the values of y.
Yeah. So whenever we calculate marginal PMF, let's say we are calculating for x, then it will be like fx of 0, right? But
Yes,
here
ma'am.
it is fx of 0 plus 2 plus 4 plus 6 plus 8, right?
Okay, it's summation of all.
Hmm.
Okay.
Kind of, but yeah, it is that only, right?
Yes.
Fx of 0, fx of 2 till fx of 8. Okay. Is this clear to everyone or still there is a doubt?
Yeah, clear.
Okay.
Clear,
If it
ma'am.
is still there, just ask me.
No, ma'am, clear.
Okay, fine. We have another question also with the same here. What is the probability that number is even and y is equal to 3? So now, probability that number is even even, and y is equal to 3. That means number modulo 7 is equal to 3. So you just tell me what kind of probability it is.
Conditional.
Joint.
Probability.
Joint.
Joint.
Okay, let's check.
Madam, it's number modulo 3, or is it like y is equal to 3? It cannot be 6, 9. If it is modulo, it can be 3,
Yeah,
6, 9, 12, right? Is it fixed on
Sorry.
3?
It's a y is equal to 3. Y is equal to 3 means?
Fixed.
Yeah.
Marginal.
Not fixed. Not fixed. Okay. Eh, Yeah, marginal. That's what my question was. Which kind of probability it is? Joint,
If,
PM,
ma'am,
joint, marginal. Yeah.
if the behavior of y is modulo 3, right?
Mm.
Then it is
Mm.
like 3, 6, everything is valid for y. But if it is y is equal to 3, then it is fixed, and then it is marginal.
Okay, but along with some another thing is also there. Just check it. Just check it.
In this thing we have to take the probability of 10, 24, 38, 52, and
Yeah,
so on.
yeah. See, the person who's saying it was a marginal PMF. So, if I want to calculate marginal PMF of any value of y, let's say fi of 3, then what I will do? I will just sum all the joint
It's
PMF of fxy, where x is taking, let's say, xi, y is taking yi, of for all the values xi belonging to, let's say, txi, right? Isn't it? We do this thing, right?
Yes.
Or you just use, I guess, ti or t1, t2, right? So if I say you, it is a t1 and this one is t1 and t2, not t1 and t2, right? T1 and 3,
Yes, ma'am.
Yes,
right?
ma'am. Yes, ma'am.
So at
Yeah.
that time, we take all the possible values that x can take, right? But in this particular case, the x is taking only even numbers. Did you get?
Yes. Yes.
So is it a marginal? No, right?
This
Because
case,
if
it is
it okay, so for that thing, I will ask you just calculate this probability also, and also calculate fy of 3. Are both same? That means you have to calculate fx of y taking value 0, comma 3. X is 0 and y is 3. Right? Like this.
Yes.
Yes, ma'am.
1
1
and
and
0.
yeah,
Until fxy
9,3.
9 and 3, right? So if we go directly, then if x is 0, then is it possible that y is taking 3? That means modulo 7 taking 3. Yeah. For 10,
24, 38.
okay, okay.
No, you need
It
to.
may get some like too much, right? Complicated. Okay, let's do it. Yeah. So what are the numbers for which y
10,
will take 3?
3,
It will be
Only
yeah.
10
3.
and 80.
24,
And
38.
Just a minute.
38,
3,
52,
10,
66.
then 24, 31,
38, man.
38, 52, 66.
45.
38. Sorry,
Not
just a minute.
45.
38, 45 now.
Yes, ma'am.
Yeah, 45,
38.
52. Then
59.
59 will be there. 66
6,
will be there. Then
73.
73. 80.
73, 80.
80.
Yeah. So there are two numbers, right? For that.
Yes.
Okay. Then 87.
Then 90.
Oh, sorry. Yeah, 94, right?
Yes.
and then 100. Right? No, not 100.
Not
Why?
100. No.
Because it's not a 2-digit, right? Okay. So
Ma'am,
Fi of
actually,
3,
I did not understand what you are doing here. So why number modulo 3 means uh, we divide the
whenever the number is divided by 7, the remainder should be 3. That's what modulo 7, like number modulo 7 is equal to 3. That means a number when divided by 7 should give remainder as 3.
Ma'am, but we have to take the intersection now between both, that y will be 3 and the x will take the even number.
Yeah, that's what that yeah, that was the question. Therefore, I just told it's not a marginal. Why? So when we calculate this Fy of 3 and both of them, then I thought you will wait. It's an intersection of x intersection y kind of things.
So
Because all these numbers are
31
not even.
45 will not come. Those numbers. Some numbers.
Yes,
Yeah,
ma'am.
yeah.
3.
Here, we told x is even. That means this 1, 2, 3,
24.
45 will not be there. 52 will be there. Yeah,
66, 80, 94.
80 and 94. Yeah.
7 by 100.
That is why it's joint, ma'am.
1, 2, 3, 4, 5, 6,
Yes,
7. Yeah,
ma'am.
7 by 100. Right?
Yes, ma'am.
Yes, ma'am.
And for that Fy of 3, what will be then Fy of 3?
All these numbers.
Yeah, 7 by 100. Yeah, all these numbers. 6, 13, 13, right?
12.
Yes, 13 by 100.
Yeah.
Okay. So, is there any doubt for this particular question? Is there any
No,
like
ma'am, how did you develop
it's
this
just too lengthy.
3,
I,
10,
I have
24?
not.
What is the logic of getting this 24?
okay? See, you know this numbers, right? 7.
Yeah,
Like all the numbers.
multiplication table you are talking about.
Yeah.
Okay.
You know all the numbers whose modulo will be who will give you a 0 remainder, right?
Right.
Okay. So
Ma'am,
yeah,
17 should
There
not be
has
there.
to be a 17 there. No? Yeah, I thought so. Yeah. Go ahead. Someone is
17. Oh,
Yeah.
I
Yeah,
missed
it's
one number. Yeah.
left, I think. Yeah.
Oh, sorry. Yeah, 17 should be there. Okay, then it will be a 14.
14.
I'm not.
Will there be any changes here? No, here it will not. Yeah.
So
Yeah.
you getting like we are generating the multiplication table and we are adding 3 to each of this number, and that is the favorable case.
Yeah, but the easiest task is you just find see your number was from 00 to 99, right? And you want a number which when divided by 7 gives you remainder 3. So out of this 00 to 99, which is the first number which when divided by 7 will give you a remainder 3?
3.
3, exactly, right? So you just add 7 to it. 7 to 8, the next number will be 10, right?
Right.
Yeah. Again, add 7 to it. The next number will give you remainder 3 when divided by 7. Why it is so?
Yeah, 10 minus, okay, 10
So
plus
I just
7.
added a 7 to all this when I created this set. Or the another scenario will be like if you know the multiples of 7, then just add 3 to it. That also works.
Ma'am, why 3 is there?
Because we have set y is equal to 3. That means number modulo 7 is equal to 3 in our question. That's why we are taking 3.
Okay.
Excuse me,
Okay.
ma'am.
Did you got the logic how we find this set?
Ma'am, I didn't get the logic of
Yeah, I got
2
it.
divided by 7. So
Sorry?
that's what I didn't get the logic of 3.
Not getting logic of 3. This
Yeah.
3.
Yes.
Okay. If I tell you the number is 3, just divide it and tell me the quotient and tell me the remainder. What is quotient? What is remainder?
Quotient
false.
0, remainder 3.
Yeah. Why it is so? We will just calculating y is equal to 3. Y is what? Number modulo 7, right?
Yes.
Number modulo 7. That means what? Y is equal to number modulo 7, which I set as 3. That means whenever the number is divided by 7, it should give me a remainder as 3, right?
Yes, ma'am.
So, yeah, maximum of the people will miss this 3 when they create this set. But your numbers are starting from 00 to 99. So, when you come with the number 3, what is your reminder for this particular number? That is 3 again, right?
Ma'am, then what's the purpose of your x variable?
X?
X, yeah, ma'am.
Sorry.
Uh, Means here, when we are considering the marginal PMF of fy of 3, and then means that's equal to fxy. So what's the purpose of xy where x is taking 0, 1, and 9? See,
Not 1 and 9. This is 1, 2, 3, and so on and
1,
on.
2, 3 up to 9, yeah.
Yeah.
So, ma'am, why don't we are considering that thing also?
We have calculated, we have considered all these things, but when we created the set, we directly got the set, right? So you can have it like, okay, fxy 0 comma 3. That means your x is taking 0 and y is 3. So what will be your joint PMF in that case? For this particular case, fxy 0 comma 3, how will you get that? How will you find this? The joint PMF of x and y, where x is taking 0 and y is taking 3. So you have to look out here, right? Find these is these are the numbers which are giving you modulo 3, right?
Yes, ma'am, yeah.
So
And
just
the
find it
workspace should be 0.
where the x is taking 0. So what is your joint PMF for fxy?
Then
0,
it
3.
would be 3, only 3.
2 by 14.
See, the table is in front of you. Just find it and tell me.
2 by 14.
Yeah, 2 by 14 or what?
Ma'am, 2 by 14.
2 by 100.
Is it 2 by
Yes,
14
yes, ma'am. It's 2 by
or 2 by 100?
2 by 100.
Ma'am, this is 2 by 14.
Ma'am, it's 2 by 14 on
2 by 14.
Why 2 by 14?
Ma'am, because we only look at the set, like what we get.
See, the
2 by 100, ma'am. I'm sorry. 2 by 100 it should be.
anyone else?
2 by 100.
What is your sample space? Your sample space is all the numbers lying between 00 to 99, right? Is it?
Yes, ma'am.
00 to 99. If this is your number, at that time I am asking you, what is the probability that x will take a number 0, sorry, not 0, yeah, 0, and y is taking value 3? Then what is the probability from this sample space
2 by
that
100.
your x is taking value 0 and y is taking value 3? Where I am saying y is equal to 3, that means the number modulo 7 should give me 3, right?
Yes, ma'am.
So just tell me how many numbers are
2 by
there.
14.
2 by 14 or 2 by
2 by
100?
100.
2 by 100.
2 by 100, ma'am. 2 by 100.
2 by 100.
2 by 100, right? Uh,
Ma'am?
is it clear to everyone or still there is a doubt with the
Ma'am, I
14
have a
and
doubt.
100?
Ma'am,
Yeah,
I have a doubt.
okay. Yeah.
Ma'am, we need to consider all those numbers.
Hmm.
where we get remainder 3.
Yeah.
So we get the this set like 3, 10, 24,
Hmm.
31.
Mm-hmm.
So it's these are 14 numbers,
Yeah.
and we need to consider only those numbers for first where unit place is
0.
0.
Yeah.
See, so we only consider this set now. That's why I'm saying 2 by 14.
Okay. 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 See. Uh, so you still confused with the 2 by 14 and 2 by 100. Okay.
Yes, ma'am.
So just tell me if your sample space is 0 to 99. Okay.
Yes, ma'am.
And I'm just asking you, just give me, just find the joint PMF where your X is taking 1 and your Y, that means modulo 7, is giving you number 3 again. Then how will you proceed with it? See, uh, it seems tricky to find out all the
1 upon
numbers.
100.
Just a minute, just a minute. Just hold it. I'm just talking to that person who has doubt. See, in this case, just 3, to find out all the numbers whose modulo 3 might be tricky, but you can find all the number whose for which X is taking 1, right? Is it?
Yes,
So
ma'am.
all the numbers will be 0, 1, 1, 1, 21, 31, 41, 51, 61, 71, 81, and 91, right? Now you have a set for which your X is taking 1. This is just a condition for X. Now you have to find among this number which is giving you 3 also, right?
Yes, ma'am.
Otherwise, out of this 100 number, you have to find all the numbers who will satisfy this condition. That's your X is taking value 1 and Y is giving you 3. So how many numbers are like that from this set?
31 only.
31.
31 only. So what will be probability then? Then what is this probability? Like out of this 100 numbers, how many numbers are satisfying both the conditions simultaneously, that your X is also taking value 1 and Y is also giving you 3? That means remainder when divided by 7 is 3. So
Only,
Only
only
1.
31 is there
yes, only one.
who will satisfy your condition that X is 1 and Y is 3. That means your probability will be 1
1 by
by
100.
11 or 1 by 100.
1
Now
by
it's
100.
1 by 100. Okay.
Okay, did you get? Now
Yes.
similarly, if I ask you, give me the probability that your X is taking value 0 and Y is taking 3, at that time, how will you proceed?
Okay.
Out of this 100 numbers, how many numbers are following both the conditions simultaneously? So your total space have 100 numbers, right? Not this
Yes.
particular. So this particular set I form to, because I like in this particular FY, when I was calculating FY of 3, I need each and everything. That's why I just okay, just find all the numbers whose modulo 3, who will give you modulo 3, right? Sorry, remainder 3. So that's why I just form this table. Now it's very easy from this table to give you fxy 0 comma 3. So just find out how many numbers are there uh, which is ending with 0. So there are only 2 numbers. That means these 2 are the only numbers out of this 100 numbers which are satisfying condition that your x is taking value 0 and y is giving you 3. So what will be fxy 03 in that case?
2
2
by
by 100 or 2 by 14?
2 by 100.
2 by 100.
And now is it clear to you or still not?
Yes, ma'am. Ma'am, clear, ma'am.
Okay. So should we
Thank you, ma'am.
move forward? Yeah. So we did here a joint PMF and marginal PMF both, right? So
No,
yeah,
in this condition, it was joint, no?
yeah.
Last case fxy, this was joint, no?
Yeah, these are joint PMF. These both joint PMF. Sorry. And that Fy of 3 was your marginal PMF. Which one? This one. Okay,
Yes.
fine. So next thing you might have learned was conditional PMF, right?
Yes.
So yeah, what is conditional PMF? Anyone?
Joint by marginal.
Yes.
No. One, like when one event happened, what is the probability of other occurring? Like
Okay.
if two random variable,
What is the
we
probability
F of
of
x y
an
divided
event
by
given that
marginal.
another event has happened?
for in case of two random variable, we say what is the probability of x taking some value when y already taken specified value.
Okay.
Ma'am, can
So
we say that event has happened given that what is the probability of another event?
yeah, yes. Let's say there is like whenever it's a conditional things, there are two concepts there. One is conditional distribution of one random variable given that another. That means, let's say in this particular case, I'm just continuing with the same example. Okay, that your number set is 00 to 99, and x is your one random variable and y is your another random variable. This is number modulo 7, and this one is unit digit. Fine. So these are two random variables. In this case, if the question is like, what is the probability of y taking some particular value, let's say 3 again, because we have calculated that. So what is the value, what is the probability that your y is taking value 3, okay, given that your x has already taken value, let's say 1. If this kind of thing is there, that what is the probability that y is taking 3 given that your x has already taken value 1? This kind of thing is conditional probability of one random variable given the another one. Okay, you have set your one random variable as fixed, and then you are finding the probability for the next random variable. Another thing, another concept with the conditional probability is that, let's say there is one event that is already happened. Let's say A and B are two events, and B is already happened, and then you are asked about is the probability that what is the probability of event A given that event B has already occurred. So this is conditioning over event, and this kind of thing is conditioning over random variable. Okay. So if someone wants to calculate this thing, like what is the conditional PMF for y, given that x has already taken value 1, then how will you proceed for that?
Joint upon marginal of that.
Okay, joint upon marginal of that. Then will you guys calculate this? Y over x is equal to 1.
Yes, ma'am, doing.
Okay.
And for which value you are asking?
Oh. Yeah, you can have presentation as this also. This
1
will
by
be
9.
like, yeah. What is 1 by 9?
And 1 by 10, I guess.
Yes.
Ma'am, I
This
think
is
1 by 10.
Yes,
Conditional probability.
probability of y equal to 3 given that x is equal to 1.
hmm. So in if it is not clear, then it is like y given x is equal to 1 equal to question mark. Yeah. So first, just calculate marginal PMF for x is equal to 1. What's that?
10 by 100.
10 by 100.
X is
Hmm.
equal to 1.
That means
Yeah.
your x is
Mm.
taking value 1.
Yeah. 1, 11, 21, like that.
That's 10 by 100.
10 by
10 by
100,
100.
1
That
upon
means
10.
okay. Okay. So I'm just taking it like just keeping it 10 by 100. So in if 100 get cancelled in further. Okay. And what will be your fxy of what? 1 comma 3, right?
1 comma 3.
Yes,
1 by 100.
It
that's
will
only
be
1 by 100.
that
1
we
by
have
100.
calculated here on, yeah,
Only 31 is the value.
31.
1 by 100. Okay. So okay. Did anyone have any question why I taken this fxy as 1 comma 3? Because what your conditional PMF says, if you want to calculate uh, conditional PMF of y, given that x is taken value 1, then what is the probability that y will take 3? So this formula will be a joint PMF of an x and y, where x is taking 1 and y is taking value 3, divided by marginal PMF for 1. Is there any doubt for this particular thing? This is just a conditional PMF formula. So I just calculated fxy of 1 comma 3, that was 1 by 100, fx of 1, that was 10 by 100. So this one is 1 by 100, 1 by 10, right?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
So this was all about conditional PMF. Okay. Then there is one concept regarding independence of random variable, right? So
Yes.
when will you say two random variables are independent?
When the product of their marginals is equal to the joint PMF.
Yes.
Okay. Like in that also, like independent variables, random variables.
When conditional PMF is equal to marginal.
That is also one thing. These are conditions, but how do you check if you
Product of
have,
marginals is equal to the joint.
yeah, your joint PMF should be equal to product of marginals. Okay, fine. So if I give you some table, will you be able to find out whether it is independent or not?
Yes, ma'am.
Yes, ma'am.
Okay, just check it. So yeah, if there is some table like, so if if the question itself says you that your random variable are independent, then what's benefit there?
Then we don't have to find joint PMF, conditional PMF of different variables. We can just multiply the marginals and find the joint,
Yeah,
or we can use the joint to find the marginals.
fine. For this particular question, you just tell me whether this is a dependent or independent.
Dependent.
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 Directly, by just
Yes, ma'am. The value
Joint is
0 is
0
present
Yes,
in
means
ma'am.
1,
that is
0.
dependent.
okay, fine. Why it is so? Just give
It
me a logical reason behind that.
Ma'am, because if we'll
The
do
marginal
the,
of T2 taking
yeah,
0 is not means actually 0. It's I think 4 by 12.
yeah, marginal of 0 is 4 by 12, and marginal of 1 as,
2
I
by
mean,
12.
yeah. and their multiplication is of course not 0.
Fine. Okay. If I change little bit, okay, but still, okay. If I change here, like, now this, now just tell me, what is it,
Independent.
sorry, dependent or independent?
It is independent.
Okay, just check it. Just take your time, just don't jump to answer.
Dependent, ma'am.
It's dependent, ma'am.
Okay, why it is so? Again, due to 0?
No, ma'am. Yeah, f of y is 7 by 12. And here
Yes, ma'am.
x of 0 is 5 by 12. 7
Yes,
by
ma'am.
12 into 5 by 12 is not 2 by 12.
Okay, will you please repeat?
Ma'am,
Yeah,
f of
that's
y,
your answer is correct. See, marginal PMF here, it for this one for FY will be 2 to 4, 7, 7 by 12, and here it will be 5 by 12.
5, sir.
So, if someone asks you, is 0 is the reason for this particular case being dependent?
No,
No,
for
ma'am.
this case,
No,
0 is not the
No.
reason.
marginals
No.
is not equal to the joint.
No, right? The reason is this one, what we say, f 1 comma 0, right?
Yes, ma'am.
When x is taking value, x is taking value 0 and y is taking 1. Fine. So that why I just modified this question. See, in this particular case, it again became dependent, but when you see 0, just directly don't claim it dependent, okay? Just check it first.
So, ma'am, there are two conditions, right? All the entries should be non-negative, first condition. And the second condition to be independent, that joint PMF should be equal of multiplication of marginal.
Multiplication, yeah. So by just looking at 0, you can claim it dependent, okay? But the reason behind for the particular PMF table or particular random variables to be dependent, it will not be always these zeros. Are you getting my point?
Yeah, like
Yes, ma'am.
if it is 0, it
Yeah.
can be independent also, right?
No.
Okay,
That's the condition you just told me.
it is 0 or equal greater than 0, right? Non-negative.
Yeah, non-negative. See, probability will be always non-negative only. How probabilities can be negative? It can't be, right?
So, ma'am, 0 is one of the condition.
It is what I know is it is non-negative. That means 0 or greater than 0.
Yeah. See, all the probabilities, whatever the event, whenever you calculate the probabilities, it will be always non-negative. Why? Because
Probabilities
Is
can be 0
defined
from 2 1.
0 to 1.
Yeah.
right? That's why it will always take values non-negative only.
Hmm.
Non-zero, then I have to check for it.
Ma'am, in this case, the joint probability of 0, comma 1 is 2 by 12. If it is independent, the marginal 7 by 12 into 5 by 12 should be
Sorry. Just a
the
minute.
value.
0, comma 1, right?
Yeah.
0, comma 1, the probability is
Joint is
2 by
2
12.
by 12.
Yeah.
So when
Um,
we multiply 7 by 12 and 5 by 12, it is not equal to 2 by 12. That's why it is not independent.
yeah,
Okay.
it is not equal to 7 by 12 and 5 by 12, right? Multiply.
Okay. Thank you.
Okay, so they may ask you, like, there might be some questions where they will ask like that, why it is dependent, then this might be one of the reason to prove it. Okay.
Ma'am, here 0 is one of the reason.
Is it? See, for whenever you calculate this joint PMF for these values, let's say fxy of 0, 0, fxy of 0, comma 0. Is it equal to fx of 0 into y of 0? Yes, it is.
Yes,
Isn't
ma'am.
it? Then then it is equal to fx of 0 into fy of 0. And if you just check with fxy of what? 1 comma 0. These are t1, right?
Yes, ma'am.
So fxy of 1 comma 0 at that time, is it equal to fx of 1 and into fy of 0?
Yes.
Yes.
Again, 3 by 12 into 0, right?
Yes.
Yes.
So this is also verified. It is also verified. Then fxy of 2 comma 0. At that time, again, fx of 2 into fy of 0, right?
Yes,
So sometimes students do just see 0 things and just check like that and claim it as a independent, right? That, oh, it's taking zeros, but all the condition, see, these are the condition for independence, right? Isn't it? The joint PMF
Yes.
should be the product of marginal. For this particular 0 row, it is satisfying the independence, right?
Yes,
But
ma'am.
still, these two random variable x and y are not independent. Why? Because when you calculate the joint PMF of 0 and 1, at that time it's 2 by 12. But your fx of 0 is 5 by 12 and fy of 1 is 7 by 12, whose product is not 2 by 12. Right?
Okay, ma'am.
Ma'am, I have a question.
Yeah.
Is there a way that we can write the joint PM of a table where 0 is one of its entry and it's independent? It's independent.
0 is one of entry and it's independent.
Yes, ma'am.
Okay. I'm not sure. I will just come up with the example or think with the example and tell you.
Okay. Okay. Thank you.
Yeah. Okay.
Ma'am, one doubt there. So in this table, like all the entries of the joint PMF values, it should be one, right? Like all the entries.
Some should be one, yeah.
Some should be one, and then if we take the marginal of f of y and f of x, and if we get that both are equal, then that could be the other approach to check whether it is independent or not. But that is lengthy, but that could be also approach, right, or not?
Yeah, that is also approach, and that approach only is you have to apply in this particular question also. That's why you got the f01 is equal to 2 by 12, which is not following independence, isn't it? If you had followed this only, then you might have claimed, okay, it's independent only. But when some person has checked f01, at that time you come up with, okay, it's independent. It's not independent, it's dependent. The first condition from the table to check whether it's dependent or not, it is like you have to take the sum of all the probabilities, that is 1 if they have given properly, and the another one is the product, like to find every joint PMF should be the product of its marginal. And with this particular 0 case, whether you directly claim with the 0, I will just confirm it in next lecture. Is it fine?
Yeah, fine.
Yeah.
So, but we have to compare this in the individual level, like how we compared if 0 of 1, that value, whether it is giving the multiplication of their marginal, like that we have to calculate one entry by one entry. If we encounter anywhere it is not equal, then we claim it is a dependent. Yeah.
Mm. Yes, that's the way. But like in general, when it's a real life data, at that time this will not be that much tricky because there are some things that will make your task easy. Okay, so should we go to next, or is there any doubt still?
Ma'am, I have one doubt, ma'am.
Yeah.
What is this marginalization, ma'am? There I didn't understand that.
Marginalization.
Yeah, and I
Okay.
have written in my notes, sum over everything you don't want. That I didn't understand that.
Sorry?
I have written sum over everything you don't want. So that I didn't understand, ma'am, how to calculate.
Sum over everything we don't want. That
Yeah,
means?
that's what I don't know, ma'am, from where I have written, but I want to understand that marginalization.
Okay, okay,
Sir
okay.
told
See,
this in
it's,
the
yeah,
lecture.
in lecture only. Yeah. See, sum over everything what you don't want, isn't it? Yeah.
Yes, ma'am.
See, the same question I am taking. 0 to 99. You're all the numbers. And whenever it's like you have to calculate uh, fy of 3 as we calculated it, so I am just going to take it again. Fy of 3, how did you calculate it? How we have calculated this value? We have done sum over all the things that we don't want. What we don't want, that what the
Means
values
we have to fix the value of x is 3,
yeah,
right, ma'am? Then we go over the y.
sum over all the things, that means this x belonging to all its range that we don't want, and fix your y as 3. Is it like did you get this? Sum over all that you don't want. See, in the
Oh, X
question
is the don't want. Okay, I got it, ma'am.
yeah.
Oh, okay, that X
See,
is okay. I got it.
don't want means whenever you calculate marginal PMF for y, at that time you know what the y will take, but you don't know what your x will take. That means x will take everything. So you have to you have to sum over everything that you don't want, or that you don't know actually.
Okay, I got it,
Right?
ma'am. That was the yeah. It's just the same calculation what we are doing. Okay, that statement
It
was
was a
okay. I got it.
language. Yeah.
That was the problem. I thought some other concept is there. Okay,
No,
thank you,
it's a
ma'am.
marginalization only. Yeah.
Okay, thank you, ma'am.
Okay, fine. Okay. So in your like there is one question with where you know that your x and y are independent, so you know that, so anyone can tell me what's the benefit of having x and y? Or see, we are taking just x and y here, but in real life or real data there will be not two random variable, there will be like lots of random variable will be there. If you know your random variables are independent, then what are the benefits you have? Anyone can just explain it?
They will have, if they are independent.
Yeah.
We can easily calculate the joint probability of the random variables, ma'am.
Okay. And anything else?
And also, ma'am, when means we can find value for any one value x1, and then we can multiply for all this n values.
Conditional will be equal to marginal in independent case.
In short, can we say that if we know all the marginal PMFs, then you know everything about the all the random variables? If you know just a marginal PMF of all the independent random variables, and they are identical also, so like can you find the joint PMF from that things? and conditional
Yes, ma'am.
also,
Yes, ma'am.
Yes,
right?
Ma'am.
But
Yes, ma'am.
at the same time, if those random variable are dependent and I give you the marginal PMF, will you come up with the joint or conditional PMFs? No, right?
No, ma'am. No, ma'am.
Yeah. That was the one thing. See, these are some, like I'm just taking one example. It may look some tricky, but it will give you more conceptual clarity. So just try it. These are some random variables that are independent and identically distributed. Okay, and they take some values, and the values are 5, 7, and 9. Okay.
So independent is fine. Identically distributed meanings, is it we are talking about the uniform distribution?
Same probability.
That means x1 has some distribution. The same distribution is followed by x2 also.
Probability is same for the all.
Yeah. No, 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 no. It's not uniform probability. See, let's say your x1 is some random variable which will take these value. Okay, see, x1 is a random variable, so it has some range. Okay, so it has some range. That range is this one: 1, 3, 5, 7, and 9. And your x1 will take all these value, not with the uniform, but with the probability. I'm just writing probability of each and everything above it, right? Let's say it's taking 1 with the probability 1 by 4, 3 with probability 1 by 2, 5 with the probability 1 by 8, and 7 with the probability 16, and the remaining will be, yeah, 16, 1 by 16. Okay, your x1 is some random variable which is taking this value 1, 3, 5, 7, 9 as its range, and probability that your x1 is taking value 1 is 1 by 4. Okay, and these are the probability for each and every value. Did you get? Is it fine for everyone what I am saying?
Ma'am, can you repeat?
Your x1 is some random variable which is taking this
Yes.
value 1, 3, 5, 7, and 9 with this probabilities given above it. Okay.
Yes, ma'am.
So x1 is random variable which has this value, and these are its probability. Similarly, x2 is again a second random variable which has these value, which is taking again these value with these probabilities. Okay. So from these probabilities, you know that this is not a uniform distribution, right?
Yes, ma'am.
Isn't it?
Yes, ma'am. Yes.
X1 and x2 is not following uniform distribution. But if someone asks you what is the distribution of x1 and what is the distribution of x2, at that time your answer will be same.
Yes, ma'am.
So this kind of thing is known as identical distribution. That the distribution followed by x1 and distribution followed by x2 are identical. That is identical distribution.
Identical means same,
Identical,
na?
yeah, identical doesn't mean uniform distribution. It's mean for that particular random variable, the distribution is same. Not
And is it possible that for identical random variables, they are taking one values 1, 3, 5, 7, 9 both, but the probabilities are different?
Yeah. Sorry. Will you please repeat?
I mean, like we take x1 and x2, we say that these are random variables that are taking values 1, 3, 5, 7, and 9, but their probabilities are different. Suppose for x1, the probabilities are 1 by 4, 1 by 2, 1 by 8, 1 by 16, and 1 by 16, but for x2, they are
Probabilities
different.
are different.
Yeah, is that possible for IIDs?
No.
Okay.
Okay. So similarly, I'm just giving you n random variables which are independent and identically distributed. Fine. That means you got now identically distributed means. all have the same
But
distribution.
identically distributed, I mean, the probabilities can be different, but the distribution should be
Yeah,
same.
yeah. Two things are identical, that means they are almost same, right? But
Yes, ma'am.
they are denoting, like when it comes to real life, if x1 is some random variable, it will denote some random thing, and x2 is denoting some another thing, but their distribution is identical, right? But they
But
are not same, but their
Yes, ma'am.
distribution is same. At that time, we say that x1 and x2 uh, have same identical distribution, or they are identically distributed.
Ma'am, here you
Hmm.
were saying x1 is taking these values like 1, 3, 5, 7, 9, and each of their probability is 1 for like that series.
Yeah, yeah.
So we are saying x2 also will take all the same values and along with the same probability.
Yes.
Okay. So let's say if we think about two fair dice and the whatever values they are taking with the probability, so in that case it is IID, right? Or it is not IID.
Two fair dice,
Yes.
and
I-
they
If we throw them for 6 times or 2 times, just trying to correlate.
okay.
So are this IID? This example what I'm saying about, talking
Yes,
about.
they are IID, and moreover, you can say uh, they are IID and also uniformly distributed.
Okay.
Yeah. Yes. What were you saying?
I mean, that is uniformly means each number has the equal 1 by 6, 1 by 6, 1
Yes.
by
Yes.
6.
Yes.
No? That is
Let
uniform.
So the correlation, I mean, that thing is like the some uniform distribution can be, or all the uniform distribution is IID. Can we say that?
all the uniform. No, 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 no. You just asked me for two fair dice.
No,
Let's say.
I'm just asking, just
Yeah,
trying
yeah.
to.
No, no, no.
But
See.
some,
Yeah, yeah. Let's say you have like two fair dice. Let's say first time you thrown one fair die, and at that time, what will be your sample space? 1 to 6, right? And all with the probability 1 by 6. At that time, you will say x1 is a uniform distribution, right?
right,
And the next time x2, right?
right,
X2
right.
means you thrown again a fair dice, and at the time your sample space will be 1 to 6, and all the probability is 1 by 6, right?
Mm, mm,
So yeah, this is then you will say x1 and x2 are identically distributed. Moreover, they are following uniform distribution also,
mm.
right? And they are
Okay.
independent also. That you can also say, right? Why independent? Because in the first throw, whatever you got with the first die and with the next die is totally independent, right? They are not related at all.
Mm. So some IID can be uniform distribute, can have this uniform distribution as well.
Yeah, the
Mm.
IID means your random variables. IID means independent and identically distributed. See, if it is a dice like thing, at that time the distribution will be this uniform distribution. That's why I'm saying in that case your distribution will be uniform. But someone just said me, what, all the uniform distribution are IID, then
Mm.
that statement is false. Why?
I was only saying that.
Okay, okay.
Yeah.
Sorry, like yeah. So can you give me the example counter for that, anyone? If the statement is just like all the uniform distribution are IID.
So two example like this fair die and coin, that
Yeah.
tossing the coin, that is also uniform, and they are at the same time IID.
Or if the die is unfair.
They are only independent, not identically distributed. See, your x1
General
is
identically distributed means the cardinality or the range is same, right?
yes.
Ma'am, can you
Cardinality,
explain it again? I am having trouble understanding.
yeah, yeah. This statement that what statement is, if two random variables are uniformly distributed, then they are what, identical or not. So the answer is they are not identical. Why? Let's say x1 is uh, throwing a die. Okay, so at that time the distribution followed by x1 will be 1 2 6, and each having probability 1 by 6, right? But and this x1 is uniformly distributed, right? X1 is following uniform distribution. Again I say okay, and x2 is tossing tossed coin. Okay, this is another event where I tossed one coin. At that time, what will be the distribution for x2? X2
Head,
will take either,
head
if I
or tail.
number it, then 0 or 1.
Yeah.
Let's
1
say
by 2.
0 is for head, and for tail I have 1. Okay. So what's the probability then? It's
1
1
by
by
2,
2,
1 by 2.
1 by 2. At that time, can I say x2 is following uniform distribution?
Yes.
So here x1 and x2 both are uniformly distributed, right?
Not identical.
They are independent also, because throwing a die and
Not
tossing a coin,
identical.
they are independent, but they are not identical.
Yes.
So
Ma'am,
x1 and x2, yeah,
I have a doubt here, ma'am.
yeah.
Isn't so for being identical, random variables should come from same probability distribution? It means sample space should be the same.
Sample space,
Should
yeah,
be the same.
yeah, yeah.
Only then it can be identical. Here, x1, sorry, x2 is tossing a coin, and x1 is uh,
Yeah, totally different in
yeah.
events.
That's why it's not identical.
Yeah, x1 and x2 are independent but not identical, right?
No, both are tossing coin, right? Or you're comparing the throwing
No,
dice and
Yeah,
one
we are
is die
comparing.
and one is coin.
okay, okay. One is
So
dice and one is coin. Okay, okay.
coin. At that time, they both are uniformly distributed for them particular cases, right?
Mm-hmm.
And both are independent also.
Mm.
They do not have to do anything with each other, but
Mm.
they are not identical.
Yeah, I got it. But if we
Okay.
compare the two dice to
Dice.
what? Yeah,
At that
two
time, it
coin.
will be
Mm.
IID.
Mm-hmm.
If your both the dice are fair dice. Okay. Do you know the difference between fair die and unfair
Yeah,
die?
yeah. The preferred die
Yeah.
is fine. All
Yeah.
the probability will
If
be yeah.
yeah. So, okay, this was all about IIDs. I was asking some other question. Right. So let's say some n IIDs are given to you. That means x1 to xn are some identical, independent and identically distributed random variables, which are following this distribution. Okay, all the xi's, x1 to xn. Is it fine to you? Then I will ask the question if it is
Yes,
clear to you. Okay. So all are
yes,
IIDs
ma'am.
and they have this distribution. At that time, if I ask what is the probability that 5 is missing in the sample?
Then one
Uh,
minus
One
probability of
minus
x is equal to 5.
what was the question actually? Sorry, I missed it.
Yeah, just a minute. Okay. Let your x1 to xn or IIDs. The question was, what is the probability that 5 is missing from the sample, from the event, sorry. Or
one minus probability of x is equal to
Means
5.
x can take values other than 5.
yeah.
Okay.
Yeah, 1 minus 1.
Then it will be 1 minus probability of 5 to the power n.
5 to the power 10.
N, the
N.
number of
Why
IIDs.
n?
Because there are n random variables and they
Okay.
are IIDs. So for every random variable,
Here is the limited. No?
Sorry.
Here is the random variable is limited, not n.
Yeah. Limited till n. Okay.
Yes, ma'am.
So probability that your 5 is missing, right? So yeah, what was it?
1 minus
1 minus probability of x is equal to
1
5.
by 8 to the power 10.
1 by 8 to the n, like whole to the power n or
No, ma'am, only to the
No,
1
only
value.
1 by 8 to the power n.
like this?
Yes.
Ma'am, can you please explain why
8.
it is whole to the power n?
Yeah, that's what. Just a minute. Is it like 1 by 8 to the power n? I doubt.
I guess one that is whole to the power n.
Just try it. How will you go? Just go with the steps. You just, I think you directly jump to the answer. So we need 5 is missing. 5 is missing means when you have n random variables at that time, you will always have to consider all the n random variables together, right?
Yes, ma'am.
So in short, I am asking you probability that x1 means this is your first x1, like first random variable, capital X1 not taking value 1, x1 is not taking value 5,
Yes.
x2 is also not taking value 5, and so on till xn is not taking value 5. Then only
Yes.
this will be the sample where 5 will be missing, right?
Yes,
If you
ma'am.
consider all this set at that time, 5 will be missing. So how will you go to
So
calculate this
first we will
probability?
take one random variable. Suppose we take x1 because all the random variables are same. So for any one we can take and we will write it as 1 minus probability of x being 5.
Yeah. Okay. Probability of, let's say, x1 being 5, right?
Yes.
Okay. What is it? It's
That is
nothing
1
but
by
1 by
8.
8.
Yes. We
So
will
probability of x1 not taking 5 is 1
1
minus
minus
1 by
1 by
Minus
8.
1 by 8.
So
7 by
now
8.
here,
Whole to the power n.
7
yeah,
by 8 whole to the power n.
it's 7 by 8. It's 7 by 8 for x1 not taking value 5. But we need 5 is missing in the whole sample. That means all the n random variables should not take 5.
Yes,
At
ma'am.
that time, we use the property that xi's are independent and identically distributed. That's why I
We
can take
can
it as
multiply them separately, no?
yeah, 7 by 8
Ma'am,
to the
why we
power.
are saying probability of x is equal to 5 is equal to 1 by 8? Your sample space is only having 1, 2, 3, 4, 5 element, right?
Yes.
But then why we are saying it is 1 by 8?
1 by 8 is probably its probability of
Given.
Oh, okay,
having
okay,
5.
okay.
Yeah.
Probability. Okay, okay. Sorry.
Yeah. So this 1 minus 1 by 8 to the power n is not correct. It should be 1 minus 1 by 8 whole to the power n. Okay. So why it was possible to calculate it, like the reason behind it was that xi's were independent and also identically distributed. If it was not identically distributed at that time, how would you have proceed?
Ma'am,
Then
I
for
have one doubt.
each random variable, we have
That
to
means
find the
at
probability
that
of.
time, just a minute. At that time, I'm just changing probabilities for each and every xi. Like for x1, the probability of having 5 is not 1 by 8. For x2, having 5 is 1 by 9, or some random values. Okay. Did you get my point? At that time, what
Yes.
will you do?
Then we will multiply them all. Means what the
Yes.
condition is,
Yeah.
and according to that,
You will not be always able to multiply it. Why?
because in IIDs the marginals are same, so we
Okay.
can consider them all together. But if we have given that they are not IIDs, so we have means in the bracket we can multiply them different.
Let's let's move your x. You have only two random variable x1 and x2, which are taking these values 1, 3, 7, 5, 9. This is for x1 only. What are these values? 1 by 2, 1 by 2, 1 by 4, 1 by 8, 1 by 16, and 1 by 16. And your x2 is following the distribution like this 1, 3, 5, 7, 9. And the probabilities for them are 1 by 4, 1 by 8, 1 by 16. Okay, it's and for these 1 by 16 and 1 by 2. Then just tell me how will you calculate probability of 5 missing? 5 is missing. Now you have only two random variables.
But minus 1 by 8.
Just a minute.
Okay.
Yeah. You just take your time, just think about it, and then reply to the question. X1 and X2 are two random variables. These are two random variables who has this kind of distribution. And then if someone is asking you what is the probability that 5 is missing,
Are they
how will
independent
you?
or not? Are these random variables independent? X1
Yeah,
and
that's what the first question you should ask. Yeah, very good. If they are independent, then only you can go for the multiplication. Otherwise, you need some more detail. You can't find out with these things. If that was the point to explain this, to write this question. These are just two
Ma'am,
random variable. You can't just go and multiply the probability of x1 not taking 5 and x2 not taking 5. Why? Because it's not given that they are independent. And you don't know from where this distribution has came, right?
But we can take addition, right? Individually, if we calculate and we can take addition, right?
Addition, like, yeah, that's what one thing is there. You just go with the probability that x1 is not taking 5. But for that, I think you need these things, no? You have to be clear. You have to be guaranteed that either they are independent or not, independent or dependent. See, if they are dependent, that means if they are dependent, like for example, whenever x1 is taking 1, at that time your x2 is taking 5. If this kind of conditions are there, then you don't know, right? So
Right.
that's why if they are not if it is not given that they are independent or not, at that time just don't go for direct multiplication. At that time you need context, you need some extra details also. Okay, that was the point to explain this question. Okay, any doubt
Oh, man.
from? Yeah.
No.
Ma'am, if it is not independent, then how can we solve it?
Yeah, then you need some more detail. You can't go with this data to calculate whether 5 is missing or not. You need some more things to solve this particular question at that time. Okay, so this was all about independence, identical. So I hope you guys are clear with independent and identical distribution, right? So
Yes, ma'am.
yeah, As of now, like there is 20 minutes left. If you guys have any question, then you can go with that, or should I continue like this only?
Maybe
Ma'am,
some
I
common
have a
pattern.
doubt from the PYQ question. Can I?
Yeah,
I have a doubt from PYQ question.
PYQ previous year. Yeah.
Yes, ma'am. Can I?
Uh, for that, I will say because this time is limited. So I think for that we can continue with that questions in doubt session, maybe in tomorrow or day after tomorrow. I think when it is.
Ma'am, will there be any old question paper solution session?
Not old paper, but you will have mock test, no? You can solve
Okay.
that and have idea from like that.
Okay, ma'am.
It may be released by today.
No,
Ma'am,
one
it
mock
was
paper
released.
already released
Yeah,
for the timing for. I mean, the end date for that is Sunday. Within Sunday, we have to solve that.
yeah. So yeah, that was that kind of thing will be there. Yeah. So one is released, right?
Yeah, ma'am. Week 1 and week 2 has been released.
Okay.
Ma'am, I have a doubt
So
with the
yeah,
expected values, ma'am. Can I go ahead?
expected values. That means yeah, for that
In
the
the
next
weekly.
session, next revision session is for that topic only.
Okay,
Ma'am,
thank
go
you.
So
for the memory less property geometry.
yeah, I was just taking that only. Yeah, memory less property. So let's say I just start with the example. If you have tossed the coin or die, whatever, 10,000 times, okay? 10,000 times you did one experiment and you got, okay, let's say you throwed a dice. Dice will be complicated, so I'm just taking coin first, then we will go to the die example. Tossed a coin 10,000 times, okay? And in all the 10,000 time, you got tail only. You got tail. You tossed a coin 10,000 times and you got tail every time. Now, if someone asks you, what is the probability that in next 500 tosses also, you will not get head?
500 n.
500 n means?
N is equal to 500, right?
Yeah. So,
No, are you saying that the first tail was got after the 10,000 time?
no. I just tell you tossed 10,000 times and in all the tosses, you got tail only.
Okay, okay, okay.
Continuously 10,000 times. Now, the question is, if you like, what is the probability that if you further toss it for 500 times, that means 10,500 times, and you didn't get head? So, what is the probability of that thing? That in next 500, after this 10,000 also, you will still get tail, tail, and tail, and so on. You will not get head. So, what's the probability for that?
We start counting one.
Considering it as 0, which is 10,001, and going till 500, so probability 1 by 500.
Probability will be
1/2 to the
1 by
power
500.
1 by 2 to the power 500. Okay.
No, actually, what I understand is from the known data, the probability of each event is 1. So it will be 500. I mean, we will get it 500 time if we go as per that.
Why?
See, because out of 10,000 times, all the time we got tail. So what is the probability here of each event? Yeah,
No,
I'm
no,
just
no, 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 no. It's not like that. See, in first coin, uh, when you tossed for the first time, at that time, what is the probability of getting tail?
1/2.
It's 1/2. Now you tossed for second time. What is the probability of getting tail?
Okay, so it is a binomial problem, right? It is probability half and n is equal to 15, what, 10,500.
Will you please repeat? Yeah.
So here the probability is half and the n is equal to 10,500.
10,500. Okay. Just take it. What is the word that in next 500 tosses you will not get head? So, is it a binomial?
I think it
Like,
is a geometric problem,
Geometric progression.
yeah, someone told it's binomial. Why? The reason behind binomial? And if someone says geometric also, then why?
Because we are searching for the head.
Means getting probability of
Getting
getting
the first head.
first tail. So
First head or tail?
first tail, man. And
Are you sure?
last.
Probability of getting first head,
Head.
because we have
First
gotten
You should
10,000
not.
tail.
See, the question is 10,000 times you tossed a coin and you got tail. That means 10,000 times you continuously got tail. Now the question is, what is the probability that in next 500 tosses you will not get head? You will not get head. That means in that 500 also you got tail. So you are searching for the first head. So whenever there are things where you have to find for the first success or first head or whatever the first thing, at that time the problem related to that is geometric distribution, right? Okay, so one step cleared, it's a geometric distribution. Now how to go with that geometric distribution?
Not getting 499 times.
Minus p to the power n minus k into p.
Sorry, please repeat, I will write here.
Into
1
p
minus
is
p
1 minus p to the power k minus 1
k minus 1 multiply by p.
What is this?
probability of
Probability.
x is equal to k,
Yeah, probability that on
where
kth time you got success, right? Got success or got head.
where k is equal to 1 2 dot 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 the infinity.
Yeah. So this is what, if you want to explain it in words, then in language, then this is what probability of x is equal to k of this. This is what first time you got, like kth, on kth turn, you got the event whose probability is p, right?
Yes, ma'am.
Isn't it? Are you getting me? Yeah. But for this particular question, this p also we know, right? For coin, fair coin, we should say.
Yeah, 1/2.
Even though
It's
it's not
1/2.
looking like a fair. Still. So it's 1/2, right? 1/2, 1/2. Isn't it?
Yes, ma'am.
Okay. But yeah, for this particular question, what is the solution? Is this the solution? This is just a distribution of geometric, right? This is the probability distribution for geometric distribution. Whenever your
So
x follows a geometric distribution, the probability is given by this, right? Now you know that in this particular question, your random variable x is following geometric distribution. But what's the solution for this particular question?
Ma'am, 1/2 raised to the power 501.
501, that means you got your head on 501th term.
Yes, ma'am.
But the question is,
499.
but
it should be 499.
Okay.
it's the question is, in next 500 tosses you do not get head. That means you may get your head on 501th term, 501th toss, or 502nd toss, or 600th toss, anything, right? Then why you fixed 501? The question is limited to 500 only.
Means until my next 500 tosses, I should not get head. But
Yeah,
after the next additional this 500 tosses, uh, in any time I can get head.
yeah.
So means if
So
X
you
is
can't
taking
fix
this
it
number of
501 only. That's my point.
if it,
Is
One
ma'am,
by 500 power n plus 1.
hello,
Yeah.
is getting head the probability of success?
Yeah. Here, in this particular question, getting the head is success.
Okay, ma'am. Thank you.
That's what this is language. You can have tail as your success also. But
So it's
in
probably
this
1
case,
minus p
we
to the power n.
then this thing will change. But the conventional method is what we search is our success. So head is the success. So this is just a geometric distribution you told. Now, what is the solution for this particular question? We are not getting that right. So, if you formulate this question in that mathematical format, then what is the question saying? Can you convert it for me? Like
ma'am.
in just notation formation, we want it. Like in 10,000, you tossed a coin for 10,000 times and you got tail. Now the question is, what is the probability that in next 500 tosses you will not get head?
And it will like that conditional probability. It is given that until 1,000 tosses, I have not get head. So
10,500 tosses you did not get head, right?
yeah,
Because next 500 tosses, that means 10,000 plus 10, this 500. So what is the probability that your x is greater than x is
X is
what?
greater than X
Getting
is
head, right?
getting head. Yeah.
Yeah. X is greater than 10,500. Why 10,500? Do anyone have doubt here? Then please ask here only.
In memory less, we can
10,500.
also consider it as 500, right?
Sorry?
In this case, in memory less, we can also consider it as just 500, right? Instead of
Yeah.
10,500.
Yes. That's where we will going to land. But I'm just going with the example. So probability x greater than 10,500, given that your x is already greater than 10,000, right?
10,000. Yes.
So we know that your this particular x is following geometric distribution. At that time, what will be the solution for this
So
particular question?
probability power
For that,
500.
ma'am, we should have the
X
probability
greater
of
than
getting
500.
Sorry?
tails and
Probability that
0.5 power 500.
500. Okay. You know the memory, I just consider you know the probably memoryless property and you know that this is equal to x greater than 500. Okay. Then the question is, what is the probability of x having greater than 500?
1 minus probability of x less than equal to 5.
Okay. Then x greater than 500, that means x is equal to 501 or x is equal to 502 or x is equal to 503. Isn't it like that?
Yes, ma'am. Yes, ma'am.
Then what should be like, how will it look like? How should it look like? Like 1 by 2.
1
1 by
minus
2,
p
that
to the power
like
n.
One minus.
probability is 1 by 2 here, right? So this
Yeah.
probability for x is equal to k in this particular case is 1 by 2 raised to the power k only, right?
Yes.
So probability x greater than 500, that is nothing but probability x is equal to 501 plus and so on. I should write two terms at least, right?
So we can also write it as 1 minus x. I think
Less
Less
than
than
equal
or
to
equal
500.
to
Yeah, yeah,
500.
yeah. That is also fine. 1 minus. That is also fine. So this will be what? 1 by 2 raised to the power 501, right?
Yeah.
Is it n plus
1
1
by
in
2
this
raised to
case?
the power 502 and so on. Yeah. What do you say?
1 by 2 power n plus 1.
Yeah. N plus 1. Why?
Ma'am, isn't there a formula for x greater
So
than x is
since
1
x
minus
is
e
equal
raised to
to
the power
k,
of
right?
x?
Here, ma'am.
X is equal to k. Yeah.
Yeah, so 501 to plus plus it goes on.
So on,
So
right?
if we
So this
so
is
k
a
plus 1.
geometric progression
Yes.
with your common ratio as 1 by 2, right? And your first term is also less than 1. So you know something, right? 1 by 2 rest to the power. The sum you know, right?
Yes.
A upon 1 minus r, right? 1 minus 1 by 2. Is it?
Yes, ma'am.
Yes, yes,
Well,
correct.
yeah, upon 1 minus r.
Right? A upon 1 minus, the first term
Yes.
upon 1 minus common ratio. So 1 minus 1 by 2, okay, 1 by 2 rest to the power 500.
Yeah.
Okay? Okay, fine. So this was just a calculation you went through, probability x greater than 500.
Ma'am,
Right?
what if it's m's greater than equal to 500? What's the formula for that?
Yeah, you have to just add x greater or equal to, na? At that time, add
Yes, ma'am.
500 also.
Oh, okay.
Yeah. If x is greater or equal to 500, then you have to include 500 also. So this is for probability x greater than 500. Now just calculate this part, because we were like almost proving memoryless property. At that time, do you think the solution will be same? Do you want to check?
No, 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 no.
Let's check it. Then why we have wrote here equal? Then it's wrong, no? Let's just check. So in language, okay, let's just calculated probability of x greater than 10,500, given that x is already greater than 10,000. Then this is just a conditional probability. You can solve it.
That will be divided
So
minus 1,000.
the first one is intersection, yeah, intersection of both of this, x greater than 10,500 and x is also greater than 10,000. That means what? It's 10,500 only, right?
Yes,
Greater than
yes, ma'am.
10,000.
X greater than 10 to 12.
10,000. So this term is probability is x. Okay. So this is nothing but probability x is greater than 10,500 divided by probability x greater than 10,000, right? Now just similarly as we done above, 10,500. So it's 1 by 2 raised to the power 10,500, right? Isn't it? Or there is any doubt? See, for if
10,501.
probability x greater than k is 1 by 2 raised to the power k. So again here also it will start with 1 by 2 raised to the power 10,501 plus 502 and so on. Then I will take, okay, common ratio is 1 by 2 and first term is 10,501. Then we subtract it. Are you getting my point, or I should write it?
Yes, ma'am. Denominator will be subtracted. Will go
Getting
Yeah.
down, will go above, and will be subtracted.
Okay, right? So
Yes.
I can directly go with this. If anyone have doubt, then let me know. I will write it. Okay. Then, yeah, again, you will minus it and it will be 1 by 2 raised to the power 500.
I
So
didn't
see,
get
both
that
are
point.
this one,
Half. No, no, no. Yeah, that one.
this particular one where I have drawn arrow, right?
Yes, yes.
Okay. See, probability of x greater than 10,500. This is what? This is equal to, how will you write it? 1 by 2 raised to the power 10,500 501, right? Plus 1
Yes.
by 2, 10,502, and so on. Why? Because x is just greater than, you don't have the upper limit, so you just go on, right?
Yeah.
Divided by this probability x greater than 10,000. So that means 1 by 2 raised to the power 10,001, 10,002, and so on, right?
Yeah.
Now, just look at this numerator here. Uh, it is just a geometric progression with common ratio 1 by 2, right?
Yes.
So you will just use the formula that first term. What is your first term in this particular numerator? 1 by 2 raised to the power what? 10,500. That's your first term, right?
Yes.
For numerator only. 10,501 divided by what's 1 minus common ratio. What's common ratio here? Yeah. What is the common ratio in numerator?
1 by 2.
So it is 1 minus 1 by 2. This denominator I am writing here, divided by. Okay, fine. For this
Yes, ma'am.
denominator, what is your first term?
1 by 2 raised to 10,000.
10,001.
Yes, ma'am.
Divided by what is your common ratio? 1 minus common ratio, right?
Yes, ma'am. 1 by 2.
Yes, ma'am.
1 by 2.
1 by 2.
So now this term 10,500. This 1 minus 1 by 2 is 1 by 2, right? So
Yes, ma'am.
this 1 by 2 will get subtracted.
Yes, ma'am.
So the resultant is 1 by 2 raised to the power 500 and 10,500.
10,500.
Right?
Yes, ma'am.
Yes, ma'am.
1,500. And this one is
1 by 2 raised to 10,000.
right.
Yes.
So yeah, here it was. Okay.
Okay, ma'am.
So yeah. So this was just a calculation part, but if we come theoretically, see, this is conditional probability. What if we convert it in language? That means what does it imply? Can anyone?
If 10,500 is, I mean, 10,500 is actually greater than 10,000. So it implies that x can be 500.
X can be 500.
Yes,
Why
it's like
it
m
happened
plus
here?
n, right? So it's already greater than 10,000, right? So
Yeah.
if x greater than 10,500, given x greater than 10,000, so we already know that it's greater than 10,000.
Yeah, that's what, that is one of the thing. But why in this particular thing? Because we have seen many examples where x is greater than 3, given that x is greater than 2, but that is not equal to x is greater than 3 directly. X is greater than 1. Why? Because that particular thing was not progression, was not following geometric distribution, and that do not possess memoryless property. What memoryless property says you is if till you tossed, you have performed some experiment and you got some results. Let's say coin only. You tossed coin for 10,000 times, but you always get tail, 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 and so on. So in your first 10,000 trials, it was tail, 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 and so on. Now someone is asking you, okay, you tossed 10,000 times. Now what is the probability that in your next 500 times also you will get tail only? That means you will not get head. Are you getting my point? If you tossed 10,000 times and next 500, then someone is asking, okay, you didn't got success in your 10,000 times, then what is the probability that in your next 500 trials also you will not succeed? At
It's
that
same as
time,
10,000.
what will you say? It is 500 times and these are 10,000 times. Okay. So you didn't succeed 10,000 times. What is the probability that you will not succeed another 500 times also. So
1 by 2 raised to 500.
yeah, that's what solution is. But what memoryless property says is, whenever you are in search of like geometric distribution where you are in search of success and you haven't succeeded for some m consecutive in first times, then the probability that you will not succeed in next time, will not succeed in next n times is equal to probability that you didn't succeed for the first n times.
Yes.
You got my point, or it is little bit confusing, but the memoryless property says that only, that if you didn't succeed 10,000 times, then at that point, if you are calculating what's the probability that in next 500 time also you will not succeed, is equal to the probability that when you started with the zero, like from the starting point, at that time, what was the probability that in next 500 you will not succeed. And if the same question is asked after some m times, then also the result will be same. That is what memoryless property. Why it is memoryless? Because it forgets about all the experiment you have did before these 500 started, before this counting after 10,000 started, right? Are you getting it or not?
Yes, ma'am.
So this is particularly for geometric only, because there are a
Ma'am,
lot of things. Yeah.
the condition should be if it is 10,000, another less than that 10,000, if it is more than 10,000
No,
cases.
10,000. This was a particular
Within,
question. I just generalize it in M also.
no, my question, if it is M, first M cases we didn't get.
Okay. M times you got failure only, or you didn't
Okay.
get. Okay.
Next M plus nth time, in that case, we can't guarantee, no?
You can't guarantee, yeah. M plus N, you can't guarantee, obviously. But yeah, what?
Okay. Yeah.
M plus N, but I didn't got your
Means
question.
within that range, another within M that less than M times, if we ask, means here it was 10,000. We are supposed to next 500, man, that is less than 10,000, no?
Yeah, 500 is less than 10,000. Okay, you are asking like that. Okay, N can
Yeah.
be greater than M also. No problem.
Okay.
N can be greater than M also. There is no restriction on N.
Okay.
Yeah. Was that your question about M and N, that which should be greater or less?
No. Is it? My question was whether whether there is any dependence on these numbers.
No. No. That's what memoryless property is. If you didn't get success on your first M times, then probability of getting success in next n times or probability of getting failure in next n time is independent of your previous trials. We'll get the same thing. Yeah. That means if there is some a real life experiment is going on, and like let's say coin only, which was actually strange, na? See, if you toss a coin and in real life only, okay, you are tossing coin and continuously 10 times, if you get tail, okay, 10 times you got tail and tail only, then your friend come and ask you what is the probability that in next two terms again, next two times again, you will not get head. What is the probability of that thing?
1 by 2 raised to 2.
Yeah, but why it is? And that means in 12 times also. Yeah, 1 by 2 raised to 2. That was correct. In 10 times you didn't get the head, and now your friend comes and asks you what is the probability that in next 2 terms also you will not get head. So you directly calculate for 2 only, not for the 12. Why? Or you can uh, go like that. Okay, probability of finding x greater than 12, right? 12, 10 plus 2, given that x was already greater than 10, right? For this, and here your x is geometric distribution and following uh, geometric distribution, so it has memoryless property, and you will go directly for the x greater than 2. Fine. Okay. Any doubt regarding the same thing or any other question that we took today?
Yeah, no doubt. But ma'am, if I may ask, what are the different type of pattern we should practice for quiz one?
Different type of questions.
Yeah, pattern. What kind of problem solving we should focus more?
Like just go through all the concepts that we have covered in like previous all the sessions, in the recorded lectures and the live sessions, solve with us and all this. That will be more than enough for that.
Ma'am, will solving GS and practice assignment is enough for quiz one?
Yeah.
Okay. Thank you, ma'am.
Okay. Thank you for today.
Ma'am, where we get these
Ma'am,
Yeah.